So this question here, we have a rocket ejecting gas at high speed. So the rocket accelerates because, so we're looking at a Y here. So when we have these word questions, the first thing we want to establish is, are the statements true? Are they factually true? Whether or not they answer the question. So the momentum of the gas is equal but opposite in direction to the momentum of the rocket. So if the rocket were stationary, it has a momentum of 0, and the momentum of the gas spilling out, the momentum of the gas coming out would be negative, but the momentum of the rocket at that moment in time is 0. So it doesn't look like the momentum of the gas is equal but opposite to the direction, to the momentum of the rocket. So we got equal and opposite. Well, yes, we would expect the rocket to move this way. And it actually says that the rocket is moving initially, so it's not at rest. It's moving. And so we are going to have gas that's going to leave, and it's going to have a change in momentum, delta P. And so for the law of conservation momentum says that there will be a change in momentum in one direction. There must be an equal and opposite change in momentum in the other. And so in that case, the rocket will change its momentum. The gas will give an impulse to the rocket, which is its change in momentum, and the rocket gives an impulse to the gas in that particular case. So the momentum of the gas is equal, but opposite in direction to the momentum of the rocket. Well, notice what we just did up here. It's the change in momentum. So if this rocket is already moving, it already has some amount of momentum. And the rocket is expelling gas. The gas is going to change its momentum, but that's not going to be equal to the momentum of the rocket. It's going to be equal to the change in momentum of the rocket. Wow. So there's a lot of detail in here, and in that finest detail, we find out that A is not a correct choice. It's not even true. The gas pushes on the air at the back of the rocket. So let's imagine inside this rocket, there is a tank like this with the gas. Now, if we're looking at where the pushing is happening, if the gas is pushing here, then the gas would go in this direction, and the rocket would go in that direction. So the gas must actually push on the front of the rocket, the front of the container in the rocket, so that the gas will push this way and the rocket will push that way. Action, reaction. But the gas is actually going to push the front of the rocket to propel it to the right. So it's actually not about the back, it's the front. So choice B is out already. That's just false. The change in momentum of the gas gives rise to a force in the rocket. Change in momentum and a force. So, well, let's look at our four-way equivalence. So the change in momentum of the rocket gives rise to a force over a period of time. So this one, there's nothing factually wrong about this in the statement. The ejected gas creates a region of high pressure behind the rocket. That is true. So the question is, which one of these explains why the rocket accelerates forward? Acceleration is mass times acceleration. Acceleration is directly proportional to the force. So the net force causes an acceleration. So the acceleration is about the force, not pressure. And it turns out if this rocket were in a vacuum in outer space, it raises a different question about whether there'll be an increase in pressure in the back, or there'll be high pressure in the back. The pressure is really, there's no pressure out there, so it's very close to 0. So for a number of lines of reasonings, we can see that choice C would be a better answer than choice D. And plus, classically, when we're looking at these situations, we're talking about momenta and forces. Pressure isn't one of those causal type relationships. Changes in motion are brought about by the law of conservation of momentum and its related concepts, force and energy. Pressure is not one of those concepts. So that's why that's the answer here for 179.